let's dive into one of the most fundamental and, frankly, incredible forces on our planet. The constant, epic journey of water that's happening all around us and deep, deep beneath our feet. Okay, so let's start with a question that's a little bit of a mind bender. Think about the water you're drinking right now. Is it possible that the very same molecules in that glass could have been sipped by, say, a T-Rex? It sounds like science fiction, doesn't it?
Well, it's not science fiction at all. The answer is yes, it is absolutely possible. And the reason why is one of the most elegant and powerful systems on Earth, the hydrological cycle. It's the very thing that makes our planet's water practically timeless.
So really, the best way to think about our planet is that it has this giant built-in water recycling system. I mean, it's been running for billions of years, and it's what sustains pretty much all life as we know it. So what exactly is the hydrological cycle? Well, it's this continuous process, and the key thing to remember is that it's all powered by the sun. The sun's energy is the massive engine that lifts water up into the atmosphere, kicking off this incredible journey through the sky, across the land, and through the oceans.
Now here's a really critical piece of the puzzle. Earth is what's called a closed system for water. That just means we don't really get new water from space, and we don't lose it either. The amount of water we have today is the same amount we've always had. It's just constantly changing its form, from ice to liquid to vapor, and moving all over the place.
So if it's all the same water, where does it actually go? Well, it's on this absolutely epic journey with a few key stages. Let's break that down. You can kind of think of this whole complex cycle as a three-act story. First up, you've got the ascent. This is where water rises up as vapor, either through evaporation from lakes and oceans or something called transpiration, which is just plants breathing out water. Next is the journey. Winds act like these giant global highways, just moving all that moisture around. And finally, the return. Water comes back down as rain or snow, flowing into our rivers and, importantly, seeping into the ground. But where does most of this journey really begin? Well, a massive 86% of all the water vapor in our atmosphere comes directly from the oceans. There's no doubt about it. They are the powerhouse of the entire global water cycle. Now, we've talked about all the water that we can see, in the clouds, in the rivers, in the oceans, but that's only part of the story. Let's talk about the hidden but absolutely crucial part of the cycle, the world that exists right beneath our feet. You see, when rain falls, not all of it just runs off into rivers. A huge amount of it actually seeps deep into the ground. It filters down and down through soil and rock until it reaches these big, saturated zones. Think of them like giant, natural underground sponges. These are called aquifers, and the water they hold is what we call groundwater. And just how much water are we talking about here? This is where it gets kind of astounding. If we take out all the water that's frozen up in ice caps and glaciers, what's left is pretty surprising. All the fresh water in all the world's rivers and lakes combined, that makes up only about 1% of the total. That hidden resource, groundwater, accounts for a whopping 30%. It's a vast, unseen ocean. And here's another key difference: time. Water in a river might be there for a few days or weeks before it's gone, but groundwater moves incredibly slowly, sometimes just a few centimeters a day. This means the water down in an aquifer could be years, centuries, or even thousands of years old. We're talking about truly ancient water. Okay, so we've got this massive, slow-moving reservoir of ancient water right under our feet. But, so what? Why is it so vitally important to our modern world?
Well, consider this. Approximately half of the entire world's drinking water is pumped up from the ground. For billions of people, groundwater isn't some abstract idea. It's the water that comes out of the tap every single day.
And the impact on our food supply? It's even more dramatic. Globally, about 70% of all the water used for agriculture, for irrigation, is groundwater. It's the invisible ingredient that helps grow the food on our plates.
And beyond our direct needs, groundwater acts as a crucial environmental safety net. During those long dry spells, it's the groundwater slowly seeping into riverbeds that keeps them from drying up completely. It's basically the planet's backup plan, sustaining entire ecosystems when the rains just don't come.
Now, this system is incredibly resilient, but it's not invincible. And our activities, well, they're putting this ancient, life-sustaining cycle under some unprecedented pressure.
The challenges really fall into three main buckets. We are pumping out too much water, which is called overextraction.
we're contaminating it with pollution from the surface that seeps down, and we are fundamentally altering the entire system through climate change.
So when we pump groundwater faster than nature can refill it, the consequences are pretty severe. The water table, which is just the upper level of this underground water, drops. Wells that have worked for generations can suddenly go dry. In some extreme cases, the land itself can actually compact and sink.
At the same time, climate change is throwing the whole cycle out of whack. It's intensifying the system. And intensifying doesn't mean better. It means more extreme. We're seeing rainfall patterns shift, leading to more severe, prolonged droughts in some areas, and more devastating floods in others.
Ultimately, it all comes down to a simple but really difficult equation. To make sure this resource is around for the long term, we have to find a way to balance what we take out with what nature puts back in.
And that leaves us with a final critical question. This water cycle powers our world, and its hidden groundwater is a cornerstone of our civilization. So the challenge for all of us is this: how do we protect and manage a vital resource that, for the most part, we can't even see?